All right, here is the overview of the valve so far. The butterfly valve looks pretty normal. There's the body, there's the disc, and it's going back and forth. Here's the shaft, there's the lobe on the shaft. Right now, we are simulating the 0 to 90 degree phase, the rotational phase. Right now, the pin, I don't have the spring constrained to the pin yet, but during this phase, the torsion spring is rotating. It's staying with the pin right there, but it's the bottom of the spring is sitting in this little saddle down here. So this is the first phase. As you can see, the camshaft is rotating one with the disc. It's one unit. All right, let's look at the other side. As you can see, it's rotating. There's the stop over here. This is going to be real critical in the next phase, but right now this is just phase one. 0, this is 0 degrees, full open, and this is 90 degrees, it's somewhat closed. Here's a different view, a section view of the valve. As you can see, it's in full open. The camshaft lobe is pointing at 45 degrees relative to the disc. And right now, the camshaft is fixed to the disc. They're acting as one piece. This is the common butterfly motion. So full open, you rotate. The operator or the actuator is rotating this camshaft clockwise, and because they're fixed together, the preload and the torsion spring, the disc is rotating 90 degrees, and it's going to rotate until it hits this stop pin right here. Okay, this angle right here and this angle, these are spherical. All around the disc, based on which has the same center as the camshaft, the small diameter. So as this rotates, this axis is fixed right here in the shaft, the small diameter here. So the idea is that there's very, very little trying to get this gap here and here as small as possible. And because it's spherical, there won't be any interference as this thing moves in and out. The seat is a circle, so it's going to be real easy to machine. The body is a circle. It's going to be real easy to machine. There's no fancy triple offset angles we got to worry about. So this is the first motion, full open. It rotates until it hits the stop there. Pretty simple. That's motion one. Full open. And then it hits. All right, that's it. That's phase one. Okay, the next motion I'm going to show you is the translation of the disc. I'm going to wedge this disc forward. It's going to translate into the seat. I'm going to wedge it in there like a globe valve. Plug that hole up, and it's going to be bubble tight. And how I'm going to do that is the camshaft right here is going to rotate. Keep rotating. You see how it's keep rotating? And the disc is translating. It's going to keep rotating until it stops. Right there. I can't push it anymore. Inventor knows when this hits this, and it won't let me turn the camshaft anymore. So right now we are jammed in there. making contact there, and all around the entire seat, top, bottom, all around. And I'm envisioning this seat Teflon, and it should coin in. There's going to be a coining in process as you assemble this valve. So once you coin it in, there's going to be some deformation in the seat there, and it should seat right in every time this seats in the future. So there you go. That's the motion 2. Let's try it again. So as you can see, it's going in and out. Okay, we get here. It hits in the motion 1, and then the camshaft continues to rotate and continues and keeps going and keeps going and keeps going. Boom, and it hits contacts right there. Any additional torque on this camshaft will help seal the valve in case there's any leakage. That wants to get by. All you got to do is provide an additional torque on the camshaft. So there you go.